Okay, here's our next new concept. It's called the Theorems of Pappus-Guldinus. Now, there's two theorems of Pappus-Guldinus, and they're pretty convenient theorems. Before we talk about them, let's say, what are we trying to do? Well, it turns out you can create a surface of revolution by rotating a plane curve about a fixed axis. Okay, so what does that mean? So we can have this arc. Here's a nice simple curve. It's a line, and if you rotate this line about this axis, you're going to create an area, and that area is going to be the shape of a sphere, or it's going to be a sphere. Well, here you can create a cone. So here's this line, right? You rotate that around this axis, and you're going to create a cone. Here you're going to create a torus, or a donut, right? So what the theorem of Pappus-Guldinus says is that the area of the surface that you create by doing this is equal to the length of the generating curve. Okay, so here, let's look at this cone. That we're saying, so you have a line, that's the curve that you're going to use to generate a cone. It's going to come around and create a cone, right? So the area of the cone is going to be the length of the line, so it's the length of the generating curve, times the distance traveled by the centroid of the curve through the rotation. Well, so where is the centroid of this line? The centroid of this line is in the middle. That's where the centroid of the line is, right? Right in the middle. So how far does this curve, does this go, the distance traveled as this goes around here? Well, it turns out it's 2 pi times y bar, right? So this is y bar times 2 pi, and that gives you the length that distance, that point, this centroid right here will travel. Where's the centroid of this torus? Well, it's going to be right in the middle, right? And so it's going to be 2 pi times its centroid to tell you how long it traveled. And so the area is 2 pi times y bar, so this is the distance that point travels, times the length of the curve itself. Okay, the second theorem of Pappus-Guldinus is the same basic idea. The first theorem, is a way to figure out the surface area, right? Well, this one is going to say, hey, if you take an area, you take, say, this half circle area and you rotate it, you're going to create a solid sphere. If you take this triangle and you rotate it around this axis, you're going to create a solid cone. Or this torus and you rotate it, you're going to have a nice little donut, right? So a body of revolution is generated by rotating a plane area about a fixed axis. And so the second theorem of Pappus-Guldinus simply says that the volume of a body of revolution is equal to the generating area times the distance it travels through the rotation. So it's the same thing. Whereas in the first theorem, you figure out how far the centroid of the curve travels. Now we're going to figure out how far does the centroid of the area. So if we wanted to figure out the volume of a sphere, say, you would come in here and you'd find the centroid of this sphere, right, which is roughly there, and you're going to find that it travels a certain distance. So it's going to travel 2 pi times y bar. So 2 pi times, and I think that ends up being 4r over 3 pi or something like that. You can look it up in the tables. That's going to be how far it travels. So that's this part, and then you multiply that by the area of the sphere. So the area of the that is being rotated, the area that is being rotated, in this case is going to be 1/2 pi r squared. And you can go through and do that and find that gives you the equation of the volume of a sphere. And so for any area, you can rotate any area and create a curve, and create a volume or a body, and you can figure out the volume of that body by doing this right here. How the distance that the centroid of the area travels times the area itself. So let's do an example of just that. It's example 5.7 in the book, where we're going to create to figure out a pulley, the volume of this pulley.